Okay, so to begin, we're going to start right at lesson 5 with your radians, your subtended arc length formula, and conversions to degrees. So the word radian is a combination of 2 words. So this pertains to a radius and an angle. So a radius and an angle. And again, we're going to do some conversions today, which are going to come right off your formula sheet. So this is just an approximation, okay? So suppose the radius of your circle is 1 inch. So go to point A and mark off 1 inch along the outside of the circle. You are just approximating. So I'm like from here to here. So I'm going to go another inch and be like right here. So I'll put a little tick mark there. I'll go another inch, I'm like right there. And right back around here. Okay. So what you're trying to show here is that those 1 inch increments mean that this half circle right now would contain what we call 3 radians. So 1, 2, 3. So 180 degrees is approximately 3 radians. So guys, how many do you think would be a 360? 6, exactly. Okay, so that's why pi is approximately 3. Obviously not completely equal to 3 because of the decimal. But so 180 degrees is approximately 3 radians. Now we have radians as an alternative way to measure angles. And what you'll see too when we do trig graphs is a radian is a typical measurement that we label a trig graph with. So in your box, in your notes, I gave you the formula to convert. What I also gave you is a formula sheet. I just accidentally threw my other one out. Now on your formula sheet, you are going to use the category that is what the problem gives you to do the conversion. So here's what I mean. So below, number 1, it says find the radian measure of each angle that is given in degrees. So on your formula sheet right now, you are going to find in degrees. Okay? So in degrees says that 1 degree equals pi over 180 radians. So that means that you take this degree measure and you are going to multiply it by pi over 180. Now, in the calculator, please do not type the pi. What you're going to do instead is, can you guys do 30 divided by 180, math, enter, enter. And what do we get? Yep, pi over 6. Excellent. So this answer is equivalent to pi over 6. All right, on to the next. 90 degrees, I'm going to do the same exact thing. So I'm going to multiply this by pi over 180. So you don't have to ever memorize this because it's on the formula sheet for you when you go to take your regents. All right, what does this one convert to, guys? Excellent, pi over 2. Keep going. So next, 300 degrees. So I go 300 times pi divided by 180. And go ahead, throw that in the calculator and hit math, enter, enter. And what do we get from that one? Excellent, 5 pi over 3. Awesome, keep going. 225. So that would be times pi divided by 180. So what is 225 over 180 reduced down to? Thank you, that's what I thought too. Yep, so 5 pi over 4. And then I gave you a negative angle. Do you think you're going to do the negative angles any different? Nope. So you're going to take that last one and multiply it as well. So I'm going to go the negative 420 degrees times pi divided by 180. And go ahead and let me know when you have that answer as well. Thank you. Negative 7 pi over 3. I should calibrate this, but I haven't yet. Go up. So that is equal to negative 7 pi over 3. Awesome. So those are your first set of conversions. And you may have seen those in the past in geometry. Didn't you guys do those last year? Okay. Sometimes they do, sometimes they kind of run out of time. So number 6, it says a circular pizza is cut into 12 equal wedge-shaped pieces. What is the measure of a central angle in radians of each wedge? Okay, what does this pizza add up to if it's circular? Good. So 360, and they're going to be real good about cutting this into 12 equal pieces. So this would be equal to 30 degrees for each piece. And then I'm going to convert it into radians. So I can do 30 times pi divided by 180, and then I'm going to reduce this. And I get, excellent, pi over 6. Okay, not bad. All right, now we're going to convert and we're going to go the other direction. So on your formula sheet, when you are in radians, you're going to use the category that says radians instead. So you use whatever you have. Now I'm going to go down to the next section, because then you don't have to memorize these. You can just keep using your formula sheet. All right, so I am going to, on the formula sheet, so find the radians. On your formula sheet, you are finding radians. So on formula sheet. Okay, so your first one is pi over 4. So I'm going to take this and I'm going to multiply it by 180 divided by pi. You guys notice anything about the pi's? They do, they cancel right off. Excellent. So this is really like 180 divided by 4. Anyone know it? Good, 45 degrees, excellent. So next, I'm going to do the same thing. I'm going to multiply top and bottom by 180 over pi. And you'll notice that when pi is there, it continues to cancel. So this is really 360 divided by 5. Someone have that? Thank you, 72 degrees. Awesome. So nice little conversion. Next, I'm going to take the 11 pi over 12, and I'm going to multiply this by 180 over pi, right off your sheet. Pi's cancel. We want to do 11 times 180 divided by 12. Does anyone have that? Say it again. 165, thank you. This is 165 degrees. And then one more conversion like this type. So we're going to do 10 pi over 9. You're going to multiply this by 180 over pi. So over pi, pi's cancel. This is equivalent to what, 200 degrees? Thank you. So 200 degrees. How you guys feel on those first couple? Are they okay? Good. Yep, so it's just a different conversion. It's kind of like when you take a measurement and you compare like inches versus feet. So it's a different alternative way to measure an angle. And we use it typically with all these trig applications. All right, so right on over. Now what you're gonna notice next is that the pi is not there. So I have an angle measure of 3.4 radians and I wanna find it in degrees. So I'm gonna do the same thing. I'm gonna do 3.45. And then I am in radians. So on my formula sheet, I want to find where it says radians. So it's the same section we were just using. So you're going to go times 180 divided by pi. And this time, you're actually going to round this off. So you're going to type that into your calculator now. So we're going to go 3.45 times 180, enter, and then divide it by pi. You guys remember where the pi key is? It is second caret. So second caret key. And I get an answer of 197 point nearest degree. So this would be 6.7. So nearest degree means this would round up to 198 altogether. Okay. 13, you're going to do the same exact thing. Convert 1.87 radians to degrees. So we go 1.87 multiplied by 180 over pi. And you're going to carefully type that in the calculator. So 1.87 times 180 divided by pi. And this is the equivalent to, did you guys get 107? Great, 107 degrees. Okay. And that brings me to these next couple. So again, a radian is just an alternative angle measure. So I gave you some circles here and we're going to calculate these values. I know some of these are a little bit tough to see. Now, the easiest way to go about doing this when you have arc length is what we refer to as the subtended arc length formula. It is very, very easy. It is S is equal to R times theta. I'll have you define all those variables on the back. I think I have a box for you in a second. S stands for subtended arc length. R stands for your radius. And theta stands for your angle in radians. So that's what RAD means on my paper. So 14 says, what is the length of arc length AB? So we don't know S here. So I'm going to go S is equal to, my radius is 3, and my angle is 2 radians. Yes, it is that easy. Answer is 6. Don't worry about a unit. Arc length AB instead. So this time I have S equals, and my radius is 8, and my angle is 1.5. So this would be equal to 12. Now I'm going to go backwards. So I gave you the arc length S. So I'm going to go 15 is equal to, and I'm going to go radius is 5, and this time theta is unknown. So 15 divided by 5 is just plain 3. Yep. And the reason that angle might look strange too is, remember, it's not in degrees, it's an angle in radians. So then my next picture on the bottom here, and then we'll summarize this in your box on the other side. So I'm going to go S equals R theta. And then I have 15 inches equal to, my radius is unknown, but my angle is 2.5 radians. So you just need to do 15 divided by 2.5. Someone have that? 6, thank you, that's what I thought. Yep, so we are equal to 6. Okay. Now, if you flip your sheet over, I believe I have a box at the top that summarizes that. Is there a box, guys? That's what I thought. I knew I'd put it somewhere. Okay, so this is called the subtended arc length formula, which is what you just used. It's very, very simple and easy to use. You just have to, unfortunately, memorize it. But it's S equals R theta, where S represents subtended arc length. That's like the outside of your circle. So it's like the crust of a pizza, if you think of it like that. So this is subtended arc length. R is clearly your radius. And theta pertains to your central angle, but it must be in radians. So if it's not in radians, you're going to have to do a conversion. Okay, so that does come up. You're going to see that in a second. So 18, I gave you word problems instead of pictures. So a circle has a radius equal to 4 inches. So I know R equals 4. What is the length of the arc? So S is unknown. Intercepted by a central angle of 2 radians. So theta is equal to 2. So I go S equals R theta and just plug them in. Answer is 8. That's it. And again, you may have seen this formula in the past. In geo, it just kind of depends on, oh, you guys didn't do circles in geo last year. That's right. You guys skipped that whole last section. I'm forgetting that. So I bet you have not seen that before. I'm sorry, I'm so used to you just doing circles at the end of the year. But it's an easy enough formula. So even if you hadn't seen it in the past, I think you guys agree you can handle it. All right, 19, a circle has a diameter equal to 12. So what do I use for the radius? Very good. So radius is equal to 6. Watch for those little things like that. What is the length of the arc? So S is unknown, and theta is expressed as 5 pi over 6. So I'm going to go S equals R theta, and I'm going to sub in. So S is equal to, and I want to go 6 times 5 pi over 6. What do you think I should do with the 6's? Yeah, just cancel them, exactly. And then go to your calculator and go ahead and type in 5 pi. And we're going to round this to the nearest 10th of an inch. Thank you. Me too. 15.7 it is. Awesome. 15.7. All right. Number 20 you can skip because there's no difference there at all. And I want you to jump right down to 21, please. And why do you suppose we need to do number 21? You have to convert. Excellent. Wonderful observation. This is 30 degrees. That is a problem because theta has to be expressed in radians instead. So your first step is to convert. So you're going to look at your formula sheet and you're going to do 30 times pi divided by 180. And this reduces down to pi over 6. And that is what you need to use in your formulas. All right, so now I'm good to go there. My radius is equal to 5. And S is unknown. So now you can advance to the formula and sub in what you have here. So S is equal to 5 times pi over 6. And nearest tenth means you guys can go right to your calculators and type that in and round accordingly. So I have 5 times 180 over 6. I'm sorry, pi over 6. Let's see. You guys get like 2.6?
Yep.
Perfect. 2.6 to the nearest 10th works for me. So 2.6. All right, questions on any of those so far? Are those pretty straightforward? Straightforward, right? Good. All right, flip all the way over to day 6 then, please. And what we're going to move into is evaluating with exact value. Now, what you need to be able to do these is all those special angle measures that you've learned in the past. So I will do this. On the top here, I'm going to draw in your 30, 60, 90 triangle and your 45, 45, 90. So up at the top here. I made that kind of small. All right, here's your 30, 60, 90. You guys remember what goes across from the 30? 1. How about the hypotenuse? 2. And the other leg is? Very good. Square root of 3. Good. So we're going to need that one. And you're going to need the 45, 45, 90. I'll do that one over here, just so I don't have to reach up as high. So here's a 45, 45, 90. I'm going to orient it like this just to change it up. And then here's 45 degrees. And here's another 45. Guys, what goes across from 45s? Good. And the hypotenuse is the square root of 2. Good. So these questions all say exact value. So that means no decimals, okay? So if something ends in a radical, you're gonna have to leave it alone. So number 1 tells me, what is the sine of 30 degrees? So go up to the triangle. Sine is opposite over hypotenuse. So what's the sine of 30? 1/2. Good. What's the cos of 60? Also 1/2. What's 1/2 times 1/2? 1/4. Done. Number 2, tangent of 60. So tangent is opposite over adjacent. So that's radical 3. And I'm going to do radical 3 times radical 3, which is equal to radical 9, which is 3. Excellent. Good catch. Yep. Or you can always use the trick that a radical times itself gives you what's underneath it. Number 3, cosine of 30 degrees. And you're going to take that and square it. So cos of 30 is the square root of 3 over 2. And I'm going to write it twice because it's squared. Sine of 30 is equal to 1/2. So you're going to plug them all in. All right, the top here, I get 3/4 minus 1/4, which is equal to 2/4, which is equal to 1/2. Okay, so just like that. All right, now I get to something different. Cosine of 180. Where is 180 located? It's not in the triangle. What else did we use, guys? The unit circle. Yep. Or to be honest with you, the cos of 180 you can type right in the calculator. So what's the cos of 180? Say it again. Yep. Excellent. So this is -1. And then the cosine of 60 is 1/2. So this would be equal to -1/2. All right, so down to the next. 45 degrees. These are where your radicals are going to come in. So sine of 45 degrees is radical 2 over 2. How about cos of 45? What's cos of 45? Yep, which is radical 2 over 2 rationalized. Yep. Sine of 30 is 1/2. So I keep going. Radical 2 times radical 2 is 2. On the bottom, 2 times 2 is 4. 2/4 is 1/2. So 1/2 plus 1/2 is equal to 1 whole. So just 1. All right, so that one worked out kind of nice. So that's good. How am I going to find the sine of 90 degrees? Calculator, yep. Sine of 90 degrees on the calculator is equivalent to 1. And then cosine of 60 is 1/2. Tangent of 45 degrees is equal to 1. So I have 1/2 plus 1, which would be equal to 1.5 or, yep, 3/2, doesn't matter. That one I'm okay if you use a decimal, obviously, because it terminates. Yep. So 1/2 and then plus 1. So 7, I have sine of 60. So sine of 60 is radical 3 over 2. And then cosine of 60, I'm going to sub in, and I'm going to get 1/2. So I get the square root of 3 over 4. Done. It's okay to have a radical in the top, just not the bottom. All right, unit circle on the next one. So sine of 30 is a triangle, that's 1/2. But guys, what is the value of sine of 270? -1. And then what is the cosine of 90? 0, yep. So this is just equal to -1/2. Good. So far, nothing that's like undefined and doesn't work. So far, so good. All right, down to number 9. What is the tangent of 0? Say it again. 0, good. Tangent of 60 is radical 3. And these are good practice ones to kind of get you thinking special angles again. So this is radical 3. All right, next value. So I have 4. The sine of 30 degrees is 1/2. Minus 2 times 1. So what is this, 0? Yep. So equivalent to 0. All right, do this. Skip down to 13. 13 is going to have some radicals that you have to kind of work with a little bit. So number 13 is cos of 30. So the cosine of 30 is radical 3 over 2. And then the cosine of 60 is 1/2. I would write these out twice because you're going to need to multiply this out. That's why I'm doing it up here, so I have a little bit more space. Plus 1/2. All right, so I'm going to FOIL that out. Just take your time with the radicals, line them up. So I do radical 3 times radical 3, which is 3. On the bottom, I do 2 times 2 is 4. Plus radical 3 times 1 is radical 3. And 2 times 2 is 4. Plus another radical 3 over 4. And then 1/2 times 1/2 is 1/4. So actually you have a common denominator, so this is not bad. I'm going to take 3/4 and 1/4 and pull them to the front. So that would give me 4/4 plus 2 radical 3, and this is all over 4. Are we allowed to leave it like this? Yeah, no, just because it does reduce. You got to go one more step. You're going to divide by 2 and leave the radical alone. So my ending answer, so divide by 2, and then divide by 2. Okay? That's, again, another type you want to be very careful with because we can't have decimals as answers. Okay. How is that page, guys? Okay? All right, I'll skip number 14 too. So you can go right over to the next page. We're going to just do a couple more of these. All right, right on over. But again, it's all just the same type of thing. And this is known as exact value. What do you notice about the next section? What are these written in? Radians, yep. So what you need to do is multiply by 180 over pi. There's a shortcut though, if you've noticed. When the pi is there and cancels, the shortcut is to actually just replace the pi with 180. Okay, so feel free to use that too. So pi is equivalent to 180. I might just speed it up for you a little bit. So this is really the tangent of 180 over 4, which is really the tangent of 45, which is equal to what, guys? You guys know this one? 1. Yep. I'm going to skip 16. We'll do 17. So 17, pi over 3. So this is like saying sine of 180 over 3, which is the sine of 60, which is equivalent to radical 3 over 2. Special right triangles. All right, 18. So I'm going to do tangent of 180 over 2. There is something special about this one. Does anybody remember it? Let's say it again. It's an error. What do we say for error? Undefined. Excellent. So this one's undefined. Can't do tan of 90. Okay. And then you'll see that I gave you quadrants for these next couple. And the reason is because these are no longer going to necessarily be first quadrant angles. Okay, so 19. What is 4 times 180 divided by 3? So divided by 3 is equal to 240. So this is equal to the cosine of 240. So here's what you got to do now. 240 falls all the way into quadrant number 3. I'm pulling on what you did last week now. How do we find a reference angle in the third quadrant? Who remembers? Excellent. Minus 180. So really, I'm asking you to do the cosine of 60. However, there's one other thing we did last week. We're not in the first quadrant. ASTC. And what do I know about cosine in the third quadrant, guys? Negative. So you're going to plug in the value now and make sure it's negative in the front. So cos of 60 is 1/2. So therefore the answer is negative 1/2. And that's how your material starts to just kind of all come full circle. All right. So number 20, we're going to do it again. So 5 pi over 6. So what is that? 5 times 180 divided by 6. Yep, thank you. I got that too. Yep, sine of 150. And I'm going to draw that because I'm not in the first quadrant anymore. So that's why it changed. So I'm going to do 150. And what is the rule for the second quadrant? Yep, sine is positive. Excellent. So I'm going to go 180 minus 150, which means I do the sine of 30, which is equal to 1/2. Good. All right, 21, tangent. So I am going to go 11 times 180 divided by 6. And I am equivalent to the tangent of, did you guys get 330? Good. So where's 330 this time? Fourth quadrant. Yep, I gave you one of each. You're going to go ASTC, because tangent is negative there. And you're going to find your reference angle. So in quadrant 4, I know it's been a couple days, you're going to go 360 minus 330. So really, I'm asking you to give me the tangent of 30 and make it negative. Tangent of 30 is radical 3 over 3 with a negative sign in the front. How do we feel in those so far? Pretty good how stuff's coming together? Okay. Next, just a couple more exact value ones. I'm going to skip around a little bit too, and we'll do a couple more of these tomorrow, so don't cross anything off. So let's see, 22 will be fine. How about, let's do 23. So 23, tan of pi over 4. So that's 180 over 4, which is equal to 45. So you're just going to convert this first, it's no harder. And then I'm going to go minus 2 times the sine of 90. Tan of 45 is 1. You guys remember sine of 90? Or know it? 1, yeah. So this answer is negative 1. All right, hop down to 26 then. You don't need to do all of these. I'm sure you've got the hang of it at this point. So 26, I'm going to sub in pi over 4. Pi over 4 is 45 degrees. I'm going to go 2 times the tan of 45 minus the sine of 45 twice. Okay, so I have 2 times 1 minus sine of 45 is radical 2 over 2. Radical 2 over 2. So I have 2 minus 2 fourths. So isn't that really just 2 minus a half, which is equal to 3 halves? Yep, very good. And we'll just do one more because they all work the same. I'm thinking where you have a little bit of space. So I guess I'll do 27 then. So 27, I'm going to sub in pi over 6. So 180 over 6 is equivalent to 30. So I do 4 times the sine of 30 plus cos of 30, cos of 30. Because squared means write it twice. Cos of 30. All right, so I have 4 times a half. And then plus cosine of 30. Do you guys know it without looking? Excellent, radical 3 over 2. And I'm sure that those are the type of things you're probably not doing this year because, you know, you can take everything at home. Under normal circumstances, you guys would know those by heart. So 4 times a half is 2. And this would be 3/4. Okay, so 2 is equivalent to 8/4. So 8/4 plus 3/4 would be 11/4. Or just, you know what, just use your calculator, hit math, enter, enter. Okay? So we'll stop there for now. Those are all just your exact value. Tomorrow we're going to just do more exact value with your reciprocal trig functions. And then again, we might start the graphs tomorrow too. I'm not sure. We're just kind of play it by ear. So that other packet that has lesson 8 in it, just keep it in your folder in case we decide to get that far. Okay? If you want to complete the rest of the problems on this page, you're more than welcome to. Same thing with the problem set. But your next unit after the evaluating trig functions is the graphs. So we're going to be doing lots and lots of graphing. Okay? Got a couple minutes to kind of get yourself situated here as well.